I know you're all expecting a teardown video, but I've got to show this off. I've set up the PC that I salvaged from the skip as a main machine, and it's great for games. You can be assured I've tested that one thoroughly. There it is. It has a weird quirk that when you switch it off and don't unplug it, it won't switch back on, but then you unplug it for a bit and then plug it back in. It's all good. Need to work out what that quirk's all about. It's a machine from a skip, so can't complain, and it works a treat. Right, to the teardown suspect. So after grabbing the laziest tripod I could, which is the gorilla one, here's our suspect. It is a drop insert access multiplexer model FM4500, made by Metrodata, we call them. And of course, well, on the front you've got various DTE ports, LEDs that would flicker to tell you their status, whether they're doing anything. But note the lack of DCE ports. Yeah, I don't think this is Cisco stuff with the lack of DCE ports. Well, it's definitely not Cisco stuff, but on the similar line, from the look of it, might be some sort of switch. Really old switch, of course. Now, side's jack shit, apart from the mounting plate. But back is where it gets interesting. So we'll bring this up nice and close to the camera within its focal range. Notice these. DTE line, we've got receive on, which is these two, and of course we've got transmitter. My guess is these hook into the main network, because this is probably going to be 90s. Back in the 90s, anyone who was in computing then and had network machines, it was pretty much BNC, but did transition over to Ethernet, but BNC ruled the day. These, I can only guess they hook to some kind of terminal, but that is pure speculation on my part. I cannot tell you for certain. This looks like a configuration terminal, so that's probably what it is. Main port. Let me get some pliers and pop that off. Well, well, well. It's a communication line interface. What a surprise. As expected, we've got the various doohickeys associated with driving BNC, which I do not know the specifics of, because these days I work in the days of Ethernet, and I really doubt I'm going to be coming across this base 10 goodies. It's not at the moment first front going with any particular transmission protocols, so this could be one of those chips which is very variable in exactly what you can get it to control the transmission of, but it's as suspected. And that pretty much covers all the notable components on this particular board, except these two relays for the BNCs. I believe they're relays by the pin count on the bottom. Another thing of note, the layering on the board, hold it up to the light, camera focuses, you notice 1, 2, flip it over, 3, 4. It's a 4-layer board. First time I've actually come across one of those. Oops, I just smashed the lens with it, but it's fine. When we bring up the main board, you'll notice there's a distinct similarity. Come on, focus, you know you wanna. There we go. From here, going to even the populated sockets down to about here, up here. You'll notice the board looks remarkably similar, even down to the 4-layer marker on the board. An interesting note, I reckon. Complete with clock crystals, which will obviously be for the FPGAs, and then we're down to pretty much the computer control logic down here, the mask ROMs to hold the ROM images, the Motorola chip, which I can pretty much guarantee 100% is some sort of processor, some relays, which actually the linkage links directly to this chip and these two relays. So let's figure out what the rest of this is, as if we don't already know. And of course, clock battery. Gonna make a guess. Real-time clock chip. Motorola chip. I'm correct. It's the microprocessor, but it's a multi-protocol support chip. Looks like designed specifically for communications applications. For example, terminal, modem interfaces. And what do we have on here? Well, we have a terminal interface for RS232, which is also labelled here. If you're watching it in HD, you should be able to see all this. We've got lots of text. We've got communication-oriented environment. We've got basic rate ISDN, or digital voice data terminal. ISDN? Sounds like something we use. After that rude jump cut from the memory card, it seems that, giving it some thought, this thing seems to be basically a multi-access point for a network to connect to the internet. Now we're talking in the 1990s here. That's labelled 96. Most of the boards are actually labelled 96 in here, in fact they both are. With of course FM4500. Rev D on that one. That one is Rev D as well. So it's looking like these are essentially, we've even got system byte, user byte, trace mode, state interrupt mark. Not quite a network packet, but then that, it's doing status register. Yeah, I was thinking, that looks, well, it's a type of packet, just not the type of packet I'm familiar with. Introduction, step summary, usual sort of belongings, and surprise, surprise, this chip here above the battery next to the clock crystal and the tuning cap is a real-time clock. That comes as no real surprise, complete with a nice block diagram there to how real-time clocks work, which even has its time save RAM and real-time clock counters. Yeah, this thing's pretty much a microcomputer just for keeping track of the time. Doesn't look like it does anything else, just so your device knows the time. And the one bombshell, can't find the data sheet for either of these two, despite the fact they were originally designed and released in 1985. Bit depressing, but I do have the laptop with me with the EEPROM reader. So, shall we see what's on the ROMs? I think so. Back to good old XP. The EEPROMs don't reveal any of their secrets. I'm not actually sure that this programmer works properly, to be honest, because it does give up a lot of false readings a lot of the time. So perhaps it needs a new parallel cable. Anyway, no secrets revealed by the EEPROMs, unfortunately. No ASCII in the side tables or anything like that. Slightly annoying, but hey, such is life. Houston, it's a bit on the dead side. We only got the power LED and no other signs of life. No flickering, no fault light, nothing. Is there even a fault light on here? Nope. So, conclusions to the teardown. Looks like some kind of early network internet access point. It doesn't look like a full-scale modem, but it would certainly link to the modem at the other end. However, I cannot be 100% sure and hope some users can put some interesting feedback. I've decided there's not much point to cracking open the power supply, it's just going to be your standard affair. However, we can measure the voltage. Bear with me. So, before we go, what are the voltages? Let me just hook up the old thing and see. 5 volts basically, or 5.11 to be exact. Haven't got my precision supply on me, so multimeter, so we don't know the preciseness of that, but hey, this thing's accurate enough. 5.11 volts, so happy little circuit. And also, is the battery any good? It's about 3.6 volts. So we'll also probe the battery. The battery is pretty dead. You know, when you're at 35 millivolts, safe to say that, yeah, you're not going to be doing much with that. Perhaps that's why it gives no life whatsoever. Oh well, such is life. Thanks for watching, and I hope you found that interesting and informative. I certainly did. Put your thoughts to whether I should put this thing back together, because I'm quite interested in the chips individually. I keep misplacing my camera, but I just couldn't resist googling it. Well, it turns out FM4500s are used in pairs with one unit at either end of a WAN. Error conditions and usage statistics are gathered and stored by the FM4500 unit. Setup is done via a comprehensive menu system which is accessed via a local or remote terminal. Well, the terminal on this one's dead. So basically it's a WAN, and you can, well, uses SNMP, which I can't remember exactly what that is right now, so Google it. And of course LAN. So yeah, interesting little bit of kit actually. Optional -48 volt DC supply. Not exactly sure we'd need that, but yeah, it's pretty much wide area length. For example, mix voice and data on the same leased line. So yeah, leased line, you connect to one of these units at each end of your WAN link, and you basically can use either data transmission, or you can go via the nice lovely route of I've forgotten where I was going. This is the problem with my brain, it does that. Oh yeah, and of course, as well as data, it can do VoIP, or voice over IP. And just for a fun note, before I kill, Windows thinks I'm not connected to the internet. I wonder how this page got to my computer. Did it have something to do with pixies? Anyway, thanks for watching. Hope you enjoyed. Interesting bit of kit. God damn, I had to find the video after I'd finished this. But yeah, that's pretty much the layout you get. Lack of DCE, which is interesting, but yeah. Basically a point-to-point WAN link. And of course your lovely LANs down there. Being from 1997, you're not going to have massive great data rates. Does it give you data rate? Here we go, bit rate. 2.48 megabits a second. Not gonna be gaming through that. Well, not easily. Would be possible, but difficult. Ethernet, 10 base T, so standard. La-di-la-di-la. That is everything on there. So yeah, I'll stick this in the description, and it'll be an interesting read for any of you who are interested. Thanks for watching. As a bonus, for the end of the video, I finally found a use for this laptop. I gave up with trying to reset the BIOS because just about every single method failed, even ripping out the EEPROMs on the motherboard. So, but I can get it to boot off disks, so it's not all doom and gloom, so that's what you do. So we're sticking on an old version of Ubuntu, and I'm going to turn it into a little CCTV system or something. Bearing in mind I recently acquired a IDE hard drive, along with an awesome vintage hard drive. Hee. Thanks for watching. It's a provision for something that was never installed. Alarm external, which is your standard PS2 connector. Might get some sort of alarm to whether there's a failure or not. And of course power. Hazard. Hazard warning. Do not open with power connected. I was going to say under normal circumstances I was going to disobey that, but not in this case. But one thing that does make me wonder, shall we hook up the terminal port and see what we get? Or shall we save that till after the teardown? We'll save that till after the teardown. Sometimes you get a little screw that decides to fray. However, there are solutions to this. When one bit fails, try another. Followed by percussive maintenance. There we go. Problem solved. Ooh, this is quite interesting inside. There we go. We'll take the camera off the tripod and give you a better view. So from here we have some EEPROMs, which we always like to see, complete with their software version, and 2 mask ROMs. We got 2 relays here, nice Motorola chip there, programmable logic gate or something there, some programmable devices here. We've got 2 Xilinx devices, in fact 3. In fact, it'll be interesting. I have a sneaking suspicion they might actually be FPGAs. And we have layer marking on the PCB. So, let's get these boards out and have a look. Thing I forgot to note, like the addition of the PSU actually being fully cased, and it only has a single output, so this isn't a 5V, 12V device, might hook up the meter and measure the output of this actually. Sorry for the crudeness, haven't installed any screen capture software yet. As I was corrected, Logic Cell Array family, or as we know them today, FPGA. Goes down, uses sort of yada yada. Now I do not fully understand FPGAs, I really only know what they are. Here is technical specs for if we can get with the highlighting, there we go. We've got one of these units on the board, which is the 64, here it is. And we've got a 42, so we've both got a binary number and the meaning of life, and the 64 is the larger of the FPGAs. Now, because they're FPGAs and I don't have any way of accessing them, we will not be able to fully know what's on them. However, there are a total of 3. So, let's go figuring out what some of the other chips are. These next chips, which are these 4 here, and of course this one up here, although I can't find a direct data sheet on them, seem to be linked to some kind of basic sort of static RAM. And of course we got our standard sort of discrete logic stuff here, and of course a few more up here. Not gonna worry searching into exactly what they are. And the last notable chip is this one. So let's find out what that one does.